Hey guys, we're here to talk about inverse functions. Let's get started. So the goal for this lesson is to find the inverse of a function or relation and determine whether two functions or relations are inverses. So let's look at writing the inverse. There are 4 steps to writing the inverse of a function. Replace f of x with y, exchange the x and y in the equation, solve for y, and replace y with the inverse of f of x. So here we have find the inverse of f of x is equal to negative 1/2 x plus 1. So here's our first step, and notice that the f of x became the y. Now I'm going to exchange the x and y in my equation. The third step is to solve for y, and so we're going to start by subtracting 1 from each side of the equal sign. Then I want to multiply both sides of the equal sign by negative 2 in order to get rid of that negative 1/2, because negative 1/2 times negative 2 will give us a positive 1. And then I replace y with the inverse of f of x. So here my final answer is, the inverse of f of x is equal to negative 2x plus 2. Remember, as we're moving through the problems, if you have any questions, be sure to write those down. One way to make sure your notes are very useful is to use colors when you can. All right, so let's do some practice problems writing the inverse for the following functions. The first function is g of x is equal to 4x minus 6. The second function, h of x is equal to x squared minus 3. Go ahead and pause the video and try your hand at writing the equation for each function. Okay, so let's look at the steps. First, I changed my g of x to y, and then I exchanged the x and y variables. Now I'm going to add 6 to both sides of the equal sign, and I get x plus 6 is equal to 4y. Now I want to divide both sides by 4, which leaves me with x plus 6 over 4 is equal to y. My final step, change the y to the inverse of f of x. Okay, here I changed my h of x to y, and I exchanged my x and my y variables. I add 3 to both sides of the equal sign, and I'm left with x plus 3 is equal to y squared. Now remember, to undo a square, you have to take the square root. So that leaves me with the result of plus or minus the square root of x plus 3 is equal to y. My last step, the inverse of h of x is equal to plus or minus the square root of x plus 3. All right, now check your progress. Pause the video so you have time to work it out, and then check and see if you got the correct answer. Correct answer is C. Okay, so here we have a very important key concept that you'll want to write down in your notes. Two functions, f and g, are inverse functions if and only if both of their compositions are the identity function. All right, so here we have it in words as well as symbols. Remember, identity function is f of x equals x. So when you perform the compositions of both functions, you should get a result of x. Okay, and this is also a reminder of what a composition is. Don't forget all of these notations down at the bottom. All of these are equivalent. You may see one of the forms whenever you're performing various compositions. Okay, so determine whether each pair of functions are inverses. F of x is equal to x minus 7, and g of x is equal to x plus 7. So I check to see if the composition of f of g and the composition of g of f are equal to the identity function. Okay, so I'll start with the composition of f of g of x. G of x is equal to x plus 7. So I substitute x plus 7 into my f function, and then I simplify. I see that the composition of f of g of x is equal to x, so this side works. Let's check the other side just to be sure. So I do the composition of g of f of x. F of x is equal to x minus 7. So I take x minus 7 and I plug it into my g function. And I simplify, and I see that I also get the identity function. The functions are inverses because their compositions equal the identity function. So here are my next functions. I need to check the compositions. Please note, it does not matter which composition you start with first, you just want to check them both. So I start with f of g of x. So this function, g of x, is equal to 2x minus 4/3. I take that value and I substitute it into my f function. I have 1/2 times 2x minus 4/3 plus 3/4. After I distribute my 1/2, I have a result of x minus 4/6 plus 4/3. In order to simplify the right side and combine like terms, I need my fractions to have common denominators. So I simplify 4/6 to become 2/3. My final result is x plus 2/3. This tells me that the composition of f of g of x does not equal the identity function. Therefore, the two functions are not inverses. Let's check the g of x composition to see, just in case you started there. So f of x is equal to 1/2 x plus 3/4. When I plug that into my g function, I get 2 times 1/2 x plus 3/4 minus 4/3. I distribute my 2 and I have a result of x plus 6/4 minus 4/3. In order to combine like terms, my fractions need common denominators. So 6/4 become 18/12 and 4/3 become 16/12. When I simplify the right side, I have x plus 2 over 12. I also can simplify this fraction to become 1/6. So this shows me that the composition of g of f of x is equal to x plus 1/6. This is not the identity function either. These functions are not inverses because their compositions do not equal the identity function. Remember, if you have any questions, please write them down in your notes. Thanks for watching.